So once again, we want to sketch the graph of the function x squared plus x plus 1. The difference between that and the last video is that instead of having a constant of -1, now it's +1. Let's see if that makes a difference. The y-intercept is, now I'm going to accelerate a bit. So this is when x is 0 and y is basically the constant part of your function. So 0, 1. The y-intercepts, how do we find those? We have to solve this. It's not too hard to convince yourself that you won't be able to apply the, or find two numbers that multiply to 1 and add up to 1. Not possible, so I'm going to start using the quadratic formula. So what's the quadratic formula again? X is minus b plus or minus b squared minus 4ac over 2a. And we get for free with that formula the x-coordinate of our vertex here, minus b over 2a. So applying this, we get what x is minus b. So b is 1 plus or minus square root of b squared minus 4 times a times c. A and c are also both equal to 1 over 2a. And what we see is that this thing here, that's negative, right? So there are no roots, no zeros exist. No x-intercept, right? This is also the same thing. So that means that our graph is going to lie either entirely above or below the x-axis. By looking at concavity, let's actually jump to concavity. I'll keep a space for vertex, but if you think about concavity, that already tells you what's happening. Concavity, well, we look at what A is, and it's positive, which means that it's concave up. So already we know it's this case that's going to happen. Or we have a function that lies completely above the x-axis, being concave up. Let's look at the vertex. So the vertex, we know its x-coordinate is minus b over 2a. That's minus a half here. Right, it's this part. Okay, because you remember, if you look at your what the x intercepts could be, it would be minus a half plus or minus the square root over 2. Now you're going to tell me there are no x-intercepts, but if I change this this 1 here in the expression to something more negative, it would actually bring down, like my curve is above the x-axis, if I change the constant and make it negative, or if I lower its value, it's going to bring down that curve, right? For example, if I have this instead, it's the y-coordinates are 2 units lower. So basically it's lowering down my curve by 2 units. Eventually, if I lower it down enough, I'm going to run into the x-axis. But what's interesting to notice is that this part, the minus b over 2a, c is not in there. So I can change the value of c and still keep the first part, the minus b over 2a, the same. So it shows you also that your vertex is still halfway between the roots once you have chosen a value of c that makes what's underneath the square root something positive. So you can anyway, you can still use the minus b over 2a as the x-coordinate of your vertex. If you're not convinced, then you should try it with this expression here. Find the roots of that. You'll see they exist, and in addition, well, actually that's our previous example, and then we've got actually roots and the vertex is halfway between them. So f of minus a half. I've calculated that for you. That's going to give us 3/4. Okay, you can do, basically you plug in minus a half into the function, so you calculate minus a half squared minus a half plus 1. So that the vertex is minus a half 3/4. And now we're ready to go. We can sketch the graph of our function. So no x-intercept. There's a y-intercept at 0, 1. Okay, what's our vertex? Minus a half. So maybe I'll put 1 here to leave me enough space to put the minus a half. Minus a half 3/4 would be here. And that's my vertex, right? One thing to notice is that this parabola is symmetrical, right? So if this is the vertex here, and then basically on each side you'll find points that have the same y value if they're at the same distance along the x-axis from the vertex. So there's probably a point here. We could check. Actually, this is minus 1 here. If I replace by minus 1, I should also get 1 for the y value. It's not too hard to see. Minus 1 squared, that's 1. Plus minus 1 plus 1, that's 1, of course. So you don't need to write down that point, but it's kind of nice to know. It's right there. And our parabola is just like that. Okay. So the important points are our vertex, minus a half 3/4, and this is the y-intercept. And once again, we're done.